Ben Holmgren and Ryan Hansen's Programming Assignment 3. I'm Ben Holmgren. I'll be doing the videoing for this one. I've got the better setup, so I'm just taking care of it. So first I'll show part 1 here. It's super simple. We so we're sending a packet that's too long. It would be cut off in the original implementation, so we just have to send 2 packets and split up the message. And the way that we did this is really simple. It's effectively just slicing strings. We just take our original message and then split it up. And we actually picked a message that was so long that it would get cut off in 3 places. So we split it up into 3 short packets. So to demo this, yeah, so yeehaw, this is one long string. It's so long we're going to need 3 packets. And we have to send it in 3 separate packets so that it doesn't get cut off anywhere. And yeah, this is our simple implementation. First off, we need to change the MTU here to 30, so we take care of that. And then we need to send segment packets generically. So we're just checking out how long this MTU value is going to let us send, how long those strings can be. And then however long that is, we're just going to divide our data string into that length versions of strings and then send those things out. And then, so that's our change in the UDT send mechanism. And then in the UDT receive mechanism, we need to reconstruct that packet for a nice output in the end. So the way that we're doing that is we're just checking each of our packets that we send should have some tag at the end. And so we're just waiting for these tags, and then based on that, we're just gluing the strings back together in the end. So to run this, to show how it's working, so we're going to send, I'm a string with a little over 80 characters the first time, or the 0th time, the first time, and the second time, I guess, and then we're going to look and see as we reconstruct those things. So yep, host 2 receives that packet, and then reconstructs it into this nice long packet based on this tag at the end, which is tag 0. And then again, we do something similar where we say, okay, tag 1 and then tag 2. So that's our implementation of part 2 of the assignment. So now I'll show the final part 3 of the project. So we need to change the simulation class to have a modified router constructor, which we do to handle routing tables, and then we need to reflect this topology. And namely, we need to send packets from host 1 through router B, and we need to send packets from host 2 through router C. And our implementation allows us to send them from either of these original hosts to whichever of the final hosts that we choose. So to demo this, let's see, so we could call host 1 and send it to, say, host 3. So what's going on? We're correctly sending from host 1 to router A, then from router A to router B, which is correct for the prompt, and then router B to router D, and finally router D to host 3. And here's our reconstructed packet that was that same packet from the last example. So now say we wanted to do the same thing but to route to host 4. Again, we correctly send through router B this time since we're starting at host 1. And we finally end up at host 4 again, which is correct. So now we could do the same exact thing for host 2, and we'll illustrate that this time we're correctly going through router C. So we're starting host 2 to router A, and then router A to router C, which is correct for host 2, and then finally to router D, and then to host 3, which we chose. And here's our fully reconstructed packet. And now lastly, we could do the same thing but end up at host 4. Great. Yeah. And again, we're going through router C, which is correct here. So I hope you enjoyed our video.